Here we are at the end of Chapter 13, friends, with Chapter 13.5, Parallelograms, Rhombuses, and Trapezoids. We're going to learn about the properties of these three figures. Let's begin. Besides squares and rectangles, there are other four-sided figures that have their own special properties. In the figure ABCD, line AB is parallel to line DC, and line AD is parallel to line BC. Figure ABCD is called a parallelogram. Here are three other examples of parallelograms. A parallelogram is any four-sided figure in which the opposite sides are parallel. We would write this like this. Line AB is parallel to line DC, and line AD is parallel to line BC. These two straight up and down lines that look like an equal sign turned on its end mean parallel. For practice, please take a look at these four figures. Which two are parallelograms and which two are not parallelograms? Now let's explore the properties of the sides and angles in a parallelogram. Let's begin with this parallelogram, ABCD. Imagine that we're going to cut the parallelogram into two pieces, right along the middle here. Then let's slide one piece to match the sides AB and DC as shown. What does this show us? It shows us that the opposite sides of the parallelogram are of equal length. Let's try this cutting along this side. If we cut the parallelogram vertically and then slide the two pieces so that AD and BC are matched up, we can say that the other pair of sides is also of equal length. Therefore, we can say that the opposite sides of a parallelogram will always be of equal length. Now let's look at the angles. We'll begin with parallelogram PQRS. Once again, we're going to cut the parallelogram in half so we can compare the angles. Let's imagine we've cut the parallelogram into two pieces across the horizontal axis. Then, we're going to make a 1/2 turn in the pieces. So I'm taking piece RS and I'm rotating it 1/2 turn and laying it on top of the piece that contains corners P and Q. What can we see happens when we align these? Right. We can see that the measure of angle P is equal to the measure of angle R, and we can see that the measure of angle Q is the same as the measure of angle S. So this tells us that the measure of the opposite angles in a parallelogram will be equal. There's one more idea to explore with the parallelogram angles. Let's take a look now. Let's take a look at parallelogram PQRS again. We're going to cut out the angles in these colored labels as shown. And we're going to put the angles together to see what type of angle will result. Here we go. When I place angle P and angle S together, I get an angle that's a straight line, or 180 degrees. And when I place angle R and angle Q together, I get another straight line, another 180 degree angle. Let's try putting the other pieces together in a different order and see what we get. This time, let's put angle P and angle Q together. Once again, we get a straight line, 180 degrees. And when we put R and S together, we also get a straight line, another 180 degrees. So, the rule that we can take away from this is that the measure of each pair of angles between two parallel sides of a parallelogram will have a sum of 180 degrees. Let's apply all we've just learned to find the unknown angle measures in a parallelogram. Let's find the unknown angle measures in parallelogram STUV. Let's begin with what we know. The measure of angle V will be equal to the measure of angle T because they are opposite of one another. Similarly, the measure of angle S will be equal to the measure of angle U, because they are opposite of one another. We also know that the measure of angle T plus the measure of angle U will equal 180 degrees, and that the measure of angle S plus the measure of angle V will also equal 180 degrees. From there, we can make some calculations that help us to find the angles that are missing. First of all, if angle T is equal to 80 degrees, then we know that the measure of angle V must also be 80 degrees, because they are opposite from one another, which means that they are equal. Now we can substitute into these equations and solve for angle S and angle U. If angle T equals 80 degrees, then angle U must equal 100 degrees. Here we have a choice. We can either substitute the value of angle V into this equation, or we can simply use what we know, which is that angle U and angle S are the same, to say that angle S will also equal 100 degrees. Please note that whenever you're given a single angle in a parallelogram, you can use the information to solve for the other three angles. Here are some practice problems for you. Find the unknown angle measures in these parallelograms. Please note that the parallelograms are not drawn to scale. There is one more problem that won't fit on the screen, so press pause while you work and move on when you are ready. Here are the last three practice programs for finding the unknown angle measures in the parallelograms. Please note that these parallelograms are also not drawn to scale. Press pause while you work and move on to the next screen when you are ready. A rhombus is a very special kind of parallelogram. Let's take a look at figure ABCD. In this figure, line AB is parallel to line DC, and line AD is parallel to line BC. In addition, the lengths of AB, BC, CD, and DA are all equal. Figure ABCD is called a rhombus. A rhombus is a four-sided figure in which the opposite sides are parallel and all four sides are of equal length. Here are three more examples. Each of these purple figures is also a rhombus. Please note that the sides are parallel and that all four sides are of the same length. And here is one final example, with the markings that show that all four sides are of equal length and that the opposite sides are parallel. I like to think of a rhombus as a parallelogram with four sides of equal length, or as a square that's kind of gotten pushed over a little bit, so it's a little lopsided. We can also see in rhombus ABCD, the blue one, that it still follows the rules for angles in a parallelogram. The measures of the opposite angles of a rhombus are equal, and the measures of each pair of angles between the parallel sides of a rhombus have a sum of 180 degrees. So other than having four sides of equal length, the rhombus follows all the same rules as a regular parallelogram. Now for your own practice, in number 9, please identify which two figures are a rhombus and which two are not. Now let's use what we know about a rhombus's angles to find unknown angle measures. The blue boxes remind us of our rules for angles in a parallelogram or a rhombus. Opposite sides are equal. So angle A and angle B are the angles between two parallel sides. Those equal 180 degrees. Angle C and angle A are opposite angles, therefore they are equal to one another. So let's find the unknown angles A, C, and D. Well, B and D are opposite of one another, therefore angle D must be equal to 65 degrees. This problem here shows us that if angle A plus angle B equals 180 degrees, then angle A must equal 115 degrees. Angle A and angle C are equal, so angle C will also equal 115 degrees. Work to solve these on your own. Find the unknown angle measures, and please note that the rhombuses are not drawn to scale. There are 2 additional problems on the next screen, so press pause and move on when you are ready. Once again, find the unknown angle measures in these 2 problems. The rhombuses are not drawn to scale. Now let's examine our last type of 4-sided figure. In some 4-sided figures, there's only one pair of parallel sides. In figure ABCD, line AB is parallel to line DC. However, line AD and line BC are not parallel. Figure ABCD is called a trapezoid. Here are 3 more examples of trapezoids. Notice that in each figure, there is one pair of parallel lines, while the other sides are not parallel. So a trapezoid is a 4-sided figure in which only one pair of opposite sides is parallel. Please look at these 3 figures in problem 14. Which one is the trapezoid, and which 2 are not trapezoids? The angles within a trapezoid have many similar properties as the angles within a parallelogram. One rule that is the same is that the measures of each pair of angles between the parallel sides of a trapezoid will have a sum of 180 degrees. So let's look at this trapezoid, ABCD, and find the unknown angle measures. So in trapezoid ABCD, line AB is parallel to line DC. The measure of angle A equals 85 degrees, and the measure of angle B equals 130 degrees. Let's find the measures of angle C and angle D. The measure of angle C plus the measure of angle B will equal 180 degrees, okay? Because they're the 2 angles between the parallel sides. We can solve by plugging in what we know. And then solve for the measure of angle C, which will be 50 degrees. Now we can do the same for the measure of angle D. The measure of angle A plus the measure of angle D will equal 180 degrees. We know that the measure of angle A is 85 degrees. And now we can solve for the measure of angle D, which will be 95 degrees. Let's finish up chapter 13.5 with these 3 practice problems. Find the unknown angle measures in these 3 trapezoids. Please note that the trapezoids are not drawn to scale. Whew, we learned a lot in this lesson. Thanks for your hard work. When I see you tomorrow, we will definitely review the problems that you practiced with, as well as visit some new ones together. Thanks for your hard work, and I will see you tomorrow.